Start, sir.
Okay. YouTube is still not live. Okay. Should I start?
So we are live. You can start now.
Okay. Good morning, good evening, friends, and thank you for being here in this live session. It is my great pleasure to interact with you, and I have never, these online courses are very strange because I have to pretend that I am teaching a large class of students, um, and I know, I mean, all of you. I mean, you, of course, for this course, you are students, but many of you are accomplished professionals in your own fields, for whom I have utmost respect. So I'm fortunate that you decided to enroll for this course. And I hope that during this course, uh, you have you have been able to gain some new knowledge, some new insights. And if that is true, then my efforts would be worthwhile. I would consider my efforts to be worthwhile. So this is a live session where which gives me an opportunity to meet you virtually again, and at least listen to you and listen to your questions, your queries, your thoughts, your views. So I would really like this to be interactive and not necessarily just it is not necessarily necessary that it has to be a doubt clearing session. Of course, if you have questions, queries, doubts, please let me know and I will try my best to answer. Uh, but more importantly, please tell me about how you like this course, what you found to be good, what you found, and more importantly, what you found were not good, and where all I can improve. Okay. So with that, I open the floor of this live session, and I look forward to your questions. Uh, Please ask me the questions from the portions that I taught. I understand that Professor PK Das has had the first live session with you, from where I mean, covering his portions, which is up till week 6. My portions start in week 7 with heat pipes, and you can ask me questions based on what I have taught between week 7 to 12. So we have a YouTube session, as you know, and your questions will come up on the YouTube chat window. And as and when the questions come up, I'll respond verbally. Keshav Balaji Kumar wishes me good evening. Yeah, same here. Good evening to you as well as all the others who are watching this session. I hope all of you are doing well. All of you are keeping safe. We are living in very strange times, unprecedented times. But there is hope. I mean, today itself, I just read that UK is going to start implementing the vaccine. They have certified the vaccine from Pfizer. So there is hope. And probably if that happens, it will be a landmark contribution to mankind. So with that positive note, I look forward to the first question from any of you. Okay, I'm still waiting for the questions. I don't see any so far. Uh, yeah, so Keshav, your question is that will there be stresses on the outer walls of the heat pipe? Mm, because there is a sudden change in volume due to evaporation. Uh, Not so much, because what happens is it's the steam or the vapor that flows through the core, and it's a liquid that comes back. Secondly, uh, typically the volume of the fluid is very low. If I talk about the small heat pipes that we see in our laptop computers, for example, there's only a few milliliters of water inside. Okay, and so therefore, yes, there will be some stresses, but if you consider, I mean, yeah, definitely you need a finite thickness of the pipe walls. They're typically made of copper, which is strong enough. So yeah, it is not that big of a concern. Okay. I mean, the other concerns like dry out, etc., where there is not enough fluid and or the entire fluid has vaporized, leading to sudden spike in temperature. So those are probably a bigger concerns. Okay. All right. Thanks, Keshav. Okay, it doesn't necessarily have to be questions. I mean, you can also give me your feedback about the course. Yes, Aniket, please go ahead. Yes. Yeah, free electrons, not so much. I mean, the electrons in a thermoelectric device, it primarily conducts electricity. Okay. And unless it's a conductor, so electrons, the vibration of molecules, I won't even say electrons, those, the heat generated is more because of conductor in conductors. But thermoelectrics are typically semiconductor devices, right? One p doped, one n doped. Okay, so therefore, there it's in these cases, it's more of the lattice vibrations of the phonons, which is the carrier of heat or thermal energy. As a result, it was important to I mean, if you can restrict the vibrations or movement of phonons, then you reduce the thermal conductivity, and so that was what was done in the early 2000s by two groups in North America. Okay, and that led to a sudden increase in the figure of merit, or ZT or ZT as we call it. Okay, so yeah, in short, in summary, the answer is that the vibration of free electrons, or the role of free electrons in conducting thermal, or in transferring thermal energy, is not that prominent in semiconductors. And thermoelectrics are semiconductor devices. By the way, the person from whom I first learned about this, and who also did a lot of pioneering work in this area, his name is Professor Arun Majumdar. Arunava Majumdar is that full name. And if you have been following news, you would have probably read that in the Joe Biden cabinet in USA, he is going to be the Secretary of Energy. Okay. Really big person. He was quite big even then when when we knew each other quite well, about 10-15 years back. But he has grown even bigger. Actually, he was the first person when Obama started what is called ARPA Energy, Advanced Research Program America Energy. So that was started in 2009, and Arun Majumdar was the first person who was asked by President Obama at that time to lead that. I think his tenure ended, then he went back, joined Stanford University as a professor. No, he's from IIT Bombay, not IIT Kharagpur. He's, I think, IIT Bombay 1986 or so, BTech. After that, he went to Berkeley, California, Berkeley, and did his PhD with Professor Changlin Tien or CL Tien, who is no more, who passed away, I think, in the early 2000s. And Professor Tien is regarded as pretty much the father of microfluidics, microscale heat transfer. So Arun Majumdar is from CL Tien's group, which has also given many other stalwarts. I think thereafter he started his professional career, academic career at Arizona State University. From there, he moved again. He moved back to Berkeley. From there to ARPA Energy. Then after that stint back to Stanford. And of course, now he's all set to take up a big role. So you see, heat transfer is not heat transfer is not such an insignificant field after all. Okay, any more questions, feedback? Okay, thank you, Shangmitra, I don't know. Thank you for your appreciation. Okay, thank you, Keshav. That's really good to know because many a times we see because there's no face-to-face interaction. It's difficult to comprehend the level of understanding of the students and set questions according to that. So I'm happy to note your comment where you are saying the assignments made you think conceptually. I'm sorry, that's my dog barking in the background. Hope you don't mind. WHRU is stands for Waste Heat Recovery Unit. Okay, Mr. Ramesh, thank you for your comment. Due to some multiple answers that lead to some miss, so I understand. I believe what you're trying to say is many a times more than one option is correct. Mm. Okay, that's good suggestion. We will look into it. Mm. But as a general rule, I think any question, of course, unless it's a numerical one, um, any theoretical question can have multiple correct answers. Okay, so that's the assumption you should go ahead with. And okay, I think we are coming towards the end of the session. So if any of you have any questions or any final questions, final comments, please go ahead.
Time up, sir.
Okay. All right. Thank you very much, everyone. It was a pleasure interacting with you on this virtual platform. I wish you all the best in the final exam and on your careers ahead. Um, I would be very happy to stay in touch after this course. If you have any questions or you just want to have a chat or discussions, feel free to drop me an email. And of course, you can find me on IIT Kharagpur website, so you will get my email address. And I'll be very happy to interact with you. Keep our interactions going. Okay. Once again, thank you very much. Have a good night. Bye.